When you imagine a number line, what do you see? It probably looks something like this, with tick marks at whatever arbitrary step you prefer. You may remember from a past math class that lines are continuous as opposed to discrete. You can zoom in as much as you'd like and always see an infinite number of numbers. Now, if we look at the electromagnetic spectrum, which is just a spectrum of radiation with visible light depicted here in the middle, you might notice a similarity. It looks just like a number line. And you may be encouraged by the word spectrum to conclude that the electromagnetic spectrum works like a number line, and that it too should be continuous with infinite shades of green, even if the human eyes can't perceive them, like many others before you have assumed. In 1900, Max Planck was experimenting with black body radiation, which is the radiation from a body that emits all energy put onto it. At high frequencies, the emission curves were well defined, like how zoomed out steps or quanta appear to be zero/continuous. But in low frequencies, the understanding at that time broke down. Planck experimentally calculated that energy increased by a constant. This is like finding out your car can only speed up by 10 miles per hour, and you just never noticed because you drove at 1,000,000 miles per hour. This explanation perfectly described the observed emission spectra, and the quantization of energy had to be accepted by the scientific community, even if they didn't like it, showing that one of the most basic assumptions in classical physics breaks down in the quantum world.